Good morning, student. Today's topic is protein. Proteins are the polymer of alpha amino acid. First of all, introduction of protein means protein occur in every part of the body and form the fundamental basis for structure and function of life. The main source of protein are milk, cheese, pulses, peanuts, fish, and meat, etc. Proteins are required for the growth and maintenance of our body. So all the proteins are the polymers of alpha amino acids. Polymer means the small units which are repeated again and again and to form a long chain, that is called as polymer. Alpha amino acid. This is the structure of amino acid. Means carbon atom which are surrounded by 4 different groups. One having carboxylic acid, another having NH2 group, and one hydrogen is present. And this carbon is attached to the R group also. R is the alkyl group. R is CH3, CH2, CH3 means methyl, ethyl, propyl. R is also replaced by hydrogen, etc. So here we see the general structure of alpha amino acid. This carbon atom that is attached to the functional group COOH. So this carbon atom is called as alpha carbon atom. The carbon which are attached to the functional group, that carbon is called as alpha carbon atom. So here write alpha amino acid. Case number 1. If R group is replaced by hydrogen, then its name is glycine. This is amino acids. Amino acids are various type. So that is carbon, COH group, NH2 group, and H. These three remain same in every structure of alpha amino acid, but only this group change. If R is replaced by hydrogen, then it will form a glycine, that is the amino acid. Glycine, it is the short form of GLY, gly, and it also write G. It is optically inactive. Only glycine is optically inactive, but all the amino acids are optically active. This is the important. All alpha amino acids are optically active except glycine. Another example of amino acid are alanine. Means the R group is replaced by CH3 group. Others group remain same. Alanine. It's a shorthand representation ALA symbol. A. It is optically active. Then another valine means R group is replaced by isopropyl group. CH, CH3, CH3. Val, and it can be written as V. This is optically active. All amino acids are optically active except glycine, in which the R group is replaced by H. Others group remain same. Then the next is the classification of amino acids. On the basis of nature, amino acids are of 3 types: acidic amino acid, basic amino acids, neutral amino acid. In acidic amino acids, if COOH group means acidic group is more than basic group, you see this example, this carbon, one hydrogen, NH2 group, COH group, that is same, but this group is changed. R group is replaced by CH2 CH2 COH. This is glutamic amino acid. In this glutamic amino acid, 2 carboxylic acid are present, but one NH2 group is present. It means this is greater than this, its number is greater than this number, na? That's why it is acidic amino acid. It is represented by GLU, glue. Next is basic amino acids. If NH2 group is greater than COH group, like this, NH2 CO CH2 CH2, this is the amino acid. Carbon, COH, NH2 and H. Here R group is replaced by CH2 CH2 CO NH2. So in this structure of amino acid, that is the glutamic amino acid, here 2 NH2 group is present. This is the R group. 2 NH2 group is present, so number of NH2 group is greater than COH. So this is the basic amino acid. But in case of a neutral amino acid, that is the third type, COH group is equal to NH2 group. You see the structure of glycine, carbon, H, COH, NH2, and R group is replaced by H. So one COH group is present, one NH2 group is present. That's why it is neutral. Means number is equal. COH group is 1, NH2 group is 1. So it is a neutral amino acid. Now the next classification of amino acid is on the basis of source. It is of two types, essential amino acids, non-essential amino acid. Essential amino acid, which cannot be synthesized in our body, and it must be obtained through the diet, means regular supply in diet. Essential amino acids are valine, leucine. These are the example of essential amino acids. Non-essential amino acids are those amino acids which can synthesized in our body, like glycine, alanine, etc. Now next is the characteristics of amino acids. First characteristics, amino acids are colorless, water soluble, and have high melting point. Amino acids are amphoteric in nature. Amphoteric means it behaves like an acid as well as base. See this structure. This is the general structure of alpha amino acid. It having one carboxylic group and one basic group, one acidic and one basic. So in this structure, both acidic and basic group are present. That's why it is amphoteric in nature. Third is crystalline solid, and it behaves like a salt. Fourth, it forms a zwitter ion or dipolar ion. This is very important. You see the structure of alpha amino acids. This group having COH group and one having NH2 group. In this alpha amino acids, COH group that release H positive ions, and this H positive is attacked by the lone pair of nitrogen, and it will form NH3 that having positive charge, and it will form COO negative charge. So in this structure, both positive and negative charge are present. So its name is a dipolar, means two poles. One is positive, another is negative, and dipolar ion is also called as zwitter ions. Now next is the configuration of amino acid. This is the general structure of alpha amino acids. If the NH2 group is present on the right hand side, then it will form D configuration, means D form of amino acids. If this NH2 group is present on left hand side, then it will form L form of amino acid. Thanks.